Today we're going to walk through some simple web pages that you can build using the things that we learned in the intro video. To get started, we're going to go over some of the basics of an HTML page, just so you kind of understand what it takes to actually make a web page or a website. This first line here tells the browser that it's an HTML document. If we go to W3 Schools, we can get a little bit more information about this. It must start with a doc type declaration, and it's used to inform the browser what kind of document to expect. And then in HTML5, which is the current version of HTML, it is just this basic tag here, and that matches what we have in the document. The next line here tells the browser what language the content is in. We go to the lang attribute. It defaults to EN for English. You can have ES for Spanish, FR for French, and so on. You can set this globally, like we've done on our document here, if all of the text on the web page is in the same language. Otherwise, you can set it on individual elements. So if you have like a translation website and you can say this one is in English, this one is in French, you can show them side by side. The next piece is this head tag. And the head element just gives some metadata about the document. And if you look over here, some of the common elements that you'll see here are title, which we have here, and that's what shows up in the browser. So like this little tag here. We have a character set, which tells it that the document's using UTF-8, which is the default character set for most programming languages. If we get to the bottom here, the slash is how we end a section. So we have the open brackets and then the tag here with the close bracket. That means everything between these two tags is in the head element. The slash means that we are going to end the head element. We can start something new. Below the head, we have the body, and this is where the main content for your web page goes. All of the stuff above here doesn't get shown in the browser. That's just to let the browser kind of know what to expect from the document. And then the body tag is where the things that the user starts to see will be put. So go to the body tag here. You can see a simple example. You've got the HTML tag, you've got a head with the title, and then you've got a body below it. H1 is a header. That means it'll be like a bolded in a larger font. P is for paragraph. That is your basic content, just like if you're just to type out a document. And there could be any number of these things inside of the body tag. One thing to take a note of here at the bottom is there's going to be one body tag inside of the HTML document. So no matter how much content you have in the page, they all go inside the same body tag. If we open up this blank document in a web browser, it just shows nothing because there's nothing to show the user yet. If we wanted to maybe give it a different title, we can call it intro. If we save that document and then we reload over here, we can see that it changes the intro up in the top. If you wanted to put some content, you can write a paragraph. If you save that and reload, it'll show up over in the browser. There are two ways that you can easily run an HTML file. The first one is if you just come to where all of your files are stored. So my project is called Fun with Randoms. They're all in this folder, and I have the different HTML files that I have open in the IDE back here. If I just double click one of them, it will open that page inside of Chrome or Firefox or whatever your default browser is set to. And this will work no matter what environment you're using if you're using Notepad to make these things. If it is a .html file, the browser knows how to open it, so when you double click one, it will open that one for you in your browser. Otherwise, if I'm inside of WebStorm here, I have this little pop-up at the top if I'm in an HTML file, and if I click Chrome, it will open this file for me in Chrome. So those are two ways that you can open these files as you're going through and creating them or editing them and see the output that you're going to have in your browser. All of the projects that we're going to build today are using this Math.random function. And what this does is just generate a random number between 0 and 1, but never 1. We're going to run this and you can see the log output that comes through. The Math.random is supposed to be generally evenly spread between all of the numbers. To check that, what we're going to do is we're going to start at 0, we're going to go up to 10,000, and we're going to do a little bit of number manipulation here. This is a line that you'll see a lot of places that use a random. If we want to generate a number between 0 and 20, but never 20, because if we come up here, we know that it never gets to 1. It'll be 0.9999999, but never 1. We'll use Math.random, and then we'll multiply it by the number we want to stop at but never get to. If we use the Math.floor function, that's going to round that number down, which means if Math.random is 8497 whatever, we multiply that by 20, and maybe it comes out to be 18.4624. The math.for will run that down to 18. So this is a very common way to get whole numbers between 0 and whatever number you're looking for. To keep track of that, what we're going to do is we have this outputs object here. We're going to use the number that we generate as the field key in the object, and then we're just going to keep a count of how many times that number shows up. Our outputs with our number key is going to be equal to our current outputs number key, or 0. And this is some shorthand JavaScript for an undefined check. So what this says is if outputs number exists, so if it is not undefined, use that. If it is undefined, since undefined evaluates to false, it's going to say or 0. At a high level, what it's going to do is look at the object. If the field's not in the object, when we try to access it here, it's going to return undefined. If that's the case, it's going to return 0. Otherwise, if it is there, it'll give us the number. And then whatever number we have there, we're going to add 1 to it, and then store that back into the map. And then once all of this is done, it will output to the console, and we can see what that spread looks like. So I've loaded the web page over here. We can see that we have Welcome to Random as our title. It's up here in the top of the tab, even though we don't see anything on the page. If we come over here to inspect, then we look at the console, which is where all of our output is. This first loop, we go 0 to 10. So just 10 random examples of what random looks like. So when we call Math.random, it's actually generating a number that looks like this. So there's a lot of precision and a lot of variation inside of here. And then if we come down below here and we do the 10,000 iterations, at the end of that, this will show the breakdown of how often the numbers occurred. So 0 occurred 472 times, 1 was 514, and so on. And you can see over a large set of numbers, everything is right around the 500 mark, which means generally speaking, we got a pretty even distribution of our numbers. And the larger you make this number, the closer all of those will start to be. So if you only did it 100 times, there is a chance that over the course of only rolling 100 of them, maybe 8 only shows up once. But as the number gets larger and larger and over a bigger and bigger data set, this even distribution starts to become more and more apparent. What we're going to do now is use the random function we just looked at to make a couple of games inside of your web browser. To do that, we're going to use a combination of HTML and JavaScript. The first new thing in this page is a script tag. What the script tag does is it lets us run JavaScript inside of an HTML file. So we'll go through the rest of the HTML and then we'll come back to what's happening up here. So instead of our body tag, we have a form. And a form is just a basic way to get input from an HTML page. And it helps you group these elements together into like a form object. It's a good way to think about it. We're going to give it an ID, and this lets us access it from the JavaScript if we need to. And then we tell it on submit, we are going to return this JavaScript output function. And what this does is every time we click this submit button down here, it's going to run this JavaScript function for us. So we're going to use this form to build the web page that we see over here. So the first thing we have is a paragraph tag. I just pushed some text out onto the page. So guess a number between 0 and 100. So we have this here. This label is the little piece that we see beside our input. So we get a label tag. We tell it what it's a label for, which is guess, which corresponds to the guess input we have down here. This is the text that actually gets output, and then we close our label. The next thing is an input. That's going to be the box we have on the page here. We have a type of number, which means if I come over here and I try to type random letters from the keyboard, it's not going to pick up most of them. That E is an exception because in a lot of math, you have E as a constant. So it will take E as an input. But if I type like J, K, L, M, N, O, P, nothing shows up. If I type numbers, the numbers do show up. And then we also get these little arrows on the side to make our number go up or down by 1. We're going to give this input an ID of guess and also a name of guess. You can use both ID and name to access elements from the HTML page. The difference being the ID has to be unique and the name can be applied to multiple elements, and then you can get all elements with that same name. What this BR here does, it's called a break, and that just tells it to move down to the next line. It's like a new line character. So the first BR moves the submit button directly under our guess input here. And then the second one just gives a little more space there, so you've got some gap between your input and your button. That's going to be everything for the form, so we're going to close that form tag off there. Then below it, we have another paragraph with an ID of response that just says start guessing. And then we have a paragraph label for our previous guesses and a UL tag. The UL tag is an unordered list, and that's just how we show like bullet points on a web page. So as you make guesses, we're going to add elements to this UL tag, and you can see your previous guesses start to show up at the bottom. If we get back up into our script tag, this is where the logic for the program is going to live. So to begin with, we're going to have a variable called current number, and this is the number that the user is trying to guess. So we have our function onGuessSubmit that gets called when they submit the form. The first thing that we're going to do is get a reference to the responses area. We're going to call that constant p, and then we're going to get a reference to our list. We're going to just call that ul. That way they're easy to remember. So if we come down here, if our current number is undefined, that means that we need to start a new game and generate a new one. So similar to before, we're going to take our current number, set it equal to this math.for so it rounds down, our random number, and then we're going to multiply it by 101. The reason we pick 101 and not 100 is, if you remember before here, it never gets to 1. So it never gets to whatever this number is at the end. When we generated our output, it was numbers from 0 to 19, but never 20. Since we want to go 0 to 100, then we need to go all the way up to 101 so that when we round down, 100 is the largest number we can get. We continue to scroll down. We have our guess element. This is going to be our guess input. We say get element by ID guess. And if we scroll down here, we can see that our number input has an ID of guess. So let's JavaScript talk to the things on the page. And then we have our user guess. This parts int just makes sure that whatever they have input is in fact a number. Even though we're using the number tag for our input down here at the bottom, since it is still a text input, that value still comes through as a string. If we were to access up here at the JavaScript level, this element.value would give me the string 10 and not the value 10. So this parse int allows JavaScript to treat that as a number instead of a string as we're going through and doing our comparisons. But what this is going to say is take whatever value is in this input. So if I come over here and I put in 10, that's going to pull that 10 value out of the input and assign that to our user guess variable. And then every time we make a guess, so that you don't have to clear out your old one and type in a new one, we're going to set that guess value to an empty string. So if I come over here and I submit one, you can see that it blanks out, and that's what this line here is doing. At this point, we have our guess from the computer, which is our current number, and then we have our guess from our user, which is our user guess. We need to start to compare those two together so we can determine if you've correctly guessed the number. Inside of each of these, we're going to have our guess result, and if your user guess is higher than the current number, we're going to create a string that says your guess of whatever your guess was is too high. And then our p element, which is this paragraph right below the input, we're going to set that to the current string that we created up here. And after that, to keep track of all your previous guesses so you don't have to remember what your guesses were, we're going to make a new li element, which stands for list item. We use this document create element to make a new HTML element by code instead of doing it in the HTML down here. We're going to say li append child, so this is how we set what's inside of that. We're going to create a text node, and we're going to set that text node to the same string that we just put into the paragraph. Then we're going to come to our UL element, which is our list down here at the bottom. We're going to call insert before. That way we can insert it at the top of the list. By default, as we make these guesses, it'll start here, and then your next one goes under it, and it keeps going down the page. But that means that your most recent guess is at the bottom of the list, and we would like it to be at the top of the list. So this insert before takes the first argument of the element that you want to put in, which is our list item we just created, and then what you want to put it in before. In this case, the UL element has this first child property, which gives us a reference to the first one. So all this says is take your list, and then whatever element we just created, insert it before the first child. And that makes our new guess always come at the top of the list. So now if I guess 12, I hit submit, 12 is at the top of the list instead of 12 being at the bottom of the list. And we're going to repeat this for the other possibilities. So the first one we checked is if your guess was too high. The next one is if your user guess is less than the current number, so that your guess is too low. And these blocks of code are exactly the same, except this one says too high, this one says too low. And then if it's not too high or it's not too low, that means that you had to have guessed the correct number. So if you guess the correct number, we're going to set our current number back to undefined, which means the next time you try to run this, it's going to come back up. It's going to say, oh, hey, it's undefined. Let's generate a new one. And that's how we're going to start a new game. The string we're going to create says your guess of whatever your guess was is correct. Input a new guess to play again. And then we're going to loop over everything in this list element. And while it has a first child, so while something is in it, we're just going to remove it. And this is what we're going to use to blank this list out. And then at the very bottom of this function that gets called from the form, we're going to return false. By default, when you submit a form, it reloads the page, and then it takes the data from the form as a payload and sends it back to the page when it refreshes. We don't want to reload the page every time because we're already handling our payload inside of this JavaScript function. So returning false here will stop it from reloading every time. So now if we go through, 12 was too low, let's do 40. 40 is too low, 50, 60, wow, 70, 80. 80 is too high, 70 was too low, 75, okay, 77, 79. There it is. So we had a correct guess of 79, and if I type in a new number, it's going to generate another random guess, and we can go again. So if we start with 50, 50 is too high. If our previous number was 79, and now 50 is too high, we know that it's picked a new one, and we can continue to play. 40, 30, 20, 10. Oh, that was a mistype. 12, nope, 13. 13 is correct. To show an example of what happens if you do end up with E inside of this input, even though it allowed us to type the E in the box, if I try to submit this, it's going to give you a pop-up saying, please enter a number. And if I delete it and go back, I can start to go back and guess again. I put E back in the box, we get that pop-up saying, please enter a number, because we told it in the code that this is a number input. And even though the E comes in, the HTML is smart enough to know that, hey, you probably don't want E to be part of your input, and we're not going to accept that until you get that out of the box. The next problem we're going to walk through is a dice roller. Anyone that's familiar with like Dungeons & Dragons or Warhammer or anything like that that uses different types of tabletop dice will be familiar with what we're about to build. So if we come down here into the form, which is the only thing different from the previous one, we have a dice form, we have onDiceSubmit that we're going to call whenever you submit it. We have a label, we have our first input of type number, that's going to be the number of dice that you're going to roll. And then the next label is just D, and in these type of systems, D refers to the number of sides on the dice. So like a D4 is a die that has 4 sides, a D6 has 6 sides. So we have our second input, which is going to be our number of sides, and then we have a submit button. And in the website, it just looks like this very basic input here. If we look up to the function, we're going to walk through what we're going to be doing here. So we get a reference to the paragraph, which is going to be our output. We have it down here at the bottom. Currently doesn't say anything, so you don't see it on the page. Our first constant is how many dice we're going to roll. So that's going to be our first input. We called it number of dice. That's going to be the one here. The second one is how many sides there are. So how many sides? It's going to be our sides element that we have here. And then we're going to do a for loop for however many dice we want to roll. So if we wanted to roll 3 dice, we would run this loop 3 times. 6 dice, we roll 6 times. And then we're going to use this very familiar looking at this point chunk of JavaScript to say we're going to generate a random number. We're going to multiply it by how many sides we say we want. We're going to round that down, and then we're going to add 1 to it. So the reason that we add 1 here is, say that I want to roll a d6. This basic piece that we've been using before will generate numbers between 0 and 5, but never 6. So since the range is correct, but they're off by 1, adding 1 to it now turns that range of 0 to 5 into a range of 1 to 6. And since you can't have a die with 0 sides, like you can never roll a 0 in these systems, this gives us the correct output that we're looking for. And then we're going to come down here for our paragraph element. We're going to set the inner HTML, which is how we set the text inside of this tag. And then we're going to output rolling however many dice you wanted to roll, and then D, however many sides you wanted to roll, equals your total, which is what we were doing here by taking each of the rolls and collectively adding them together. So if I come here and I say I want to roll 3D6, I roll that, I got a 16, an 11, a 5, oh, that was a bad roll. 11, 11, 9, and it can get obnoxious. So if I want to say that I want to roll 13 D74s, even though there is no D74 die, it'll tell me if I roll 13 D74, I get a total of 407. Our next project is going to be writing a magic 8-ball. It's a toy that, you ask it a question, you shake it, and it gives you a random response. We're going to emulate that inside of this basic web input here. So if we look at our form, we have an onQuestionSubmit function, which is what we're going to get called up here. We have our label, we have our question input. This time our input is type text, which means I can come up here and I can type in whatever I want to inside of this thing. It'll take numbers, it'll take punctuation marks, it'll take brackets. So this is essentially an unfiltered input. And then we have our submit button, and then the response down here at the bottom like we've been doing before. So we come to the script tag and look at the JavaScript we have. This is our array of responses. And these are all of the responses that your basic magic 8-ball, like you can go out to the store and pick up, have inside of it. And the way that the 8-ball works is all of these are on the different sides of a die, and then you shake it and the die gets rolled up and then it floats to the top and you can see your response. What we're going to do is just mimic that using a little bit of JavaScript. So what we need to do is we need to come down here and we need to generate the random index. So we're going to use our math for and the Math.random, and what we're going to multiply by is the length of our responses. As we add more responses up here, we don't need to necessarily come down here and change whatever number we want to use to limit our range. This will automatically get updated. And then we're going to get a reference to our paragraph tag, and then we're going to set the inner HTML to whatever random index we pulled out of this responses array. And then we're just going to return false like we've been doing to stop the form from reloading. What we're not doing is taking what's in this box into consideration. We don't really care if it's blank, it'll still work. If we add something random inside of there, it'll still work. So we're not actually making it ask a question, and that's something that you could do to improve upon this. So you can kind of look at the question and determine maybe what output you would like to give. Otherwise, you can pick a random one. But if I just keep submitting this, it's just going to pick a random output every time. The last project we're going to look at today is rock, paper, scissors. So we're going to essentially make the web page play the game of rock, paper, scissors with us. We come down here. We have our form like we've been doing before. We have our onSubmit function. We have a paragraph that tells us please select our move. And then we have a radio input. What this input does is it only allows you to select one from the group. We gave them all the same name. That's user move. And what that means is for all of the radio inputs with this name user move, only one of them can be selected. So if I come here and I pick rock, and then I try to pick paper, it deselects rock for me. So that makes sure that the user can only select one of these at a time. If you wanted to be able to select multiples, you would use something like a checkbox, and you could just go through and check the ones that you wanted to use. So we have our 3 radio inputs. All of them are labeled rock, paper, scissors. This value is whenever we reference it in JavaScript, that's the value that we're going to pull out. In this instance, it happens to also match our label. But you can make the value something that is easier for the computer to recognize, and then make the label something that is easier for the user to recognize. And then we have our response down here at the bottom, like we've been doing, to let the user know, did they win, did the computer win, or did they tie? If we open up our function, the first thing we're going to do is pick a random index from our selections list up here, and that's going to be the move from the computer. We're then going to come down here and get a reference to our paragraph element so we can give the output. So we take our game selection, and then we use our selections from up top and our random index that we just generated up here for the computer's random move. The next thing we need to do is get the user's selection. Before, we've just been using getElementById to get the one thing that we need from the form. What we're going to do is something called a query selector now, and this lets us sort of build a question to ask to the web page. What this is going to say is give me everything of type input, and our radio buttons are inputs, where the name equals user move, so that would give us all three of them. And then this colon checked is like a pseudo property, and what that means is only return the one that has the checked value. So it'll filter out the two I haven't selected, and in this case it'll just return scissors. And then I call .value to get the value that we set down here. So that will give us our user selection, and now we need to go through and determine the winner. So we're going to default to the user winning, and then we're going to look for all of the instances where that wouldn't be true. We're going to use a switch case instead of a bunch of if statements here. And a switch is just like a supercharged if. So we're going to pass in our user selection, and then we have all of these different cases. And if we were to write this as an if statement, we would say if user selection triple equals rock. And then this is what would be inside of our brackets. And then below that, we would have else if user selection triple equals paper. And then this would be our next section. So the switch statement, as you start to get more and more of these, makes it a little easier to read what's going on. So if we start to step through this, we'll say, okay, so when the user selection is rock, we are looking for cases to make you not win, because we're defaulting to you winning. So if the game picked paper and rock beats paper, did user win get set to false? And then we break. And what this break means is to skip the other cases that we've handled it here. And then if user selection is paper, it'll say, okay, well, if the user picked paper, if the game picks scissors, then the user did not win, and then we'll break out. And then if the user picked scissors, it'll look for rock and say, okay, rock beats paper, user did not win, and break out. And then the last thing we have to look for is a tie. So if the game selection and the user selection are the same, then you both pick rock or you both pick paper, and we're going to output you tied. Otherwise, if the user won, we're going to output you won, and then what your selection was, and then that selection beats whatever the game selection was. Otherwise, if you didn't tie and you didn't win, that means that you lost. We say you lost, and then tell you that the game selection beats your selection. And then we're going to return false at the end to stop the web page from reloading. So if I come back over here, I have scissors selected. I'm going to submit. We tied. I won. Scissors beats paper. We tied. I lost. Rock beats paper, or rock beats scissors. Go back to paper. Scissors beat paper. You can play this forever, and the computer will generate a different selection every time.